Okay, so welcome. So my name is Philippe Bertin. I am working for Orange Labs, and I am showing here a demonstration of a new mobility scheme, which is developed in the framework of OCONS. OCONS means Open Connectivity Services. So it's new types of managing connectivity within networks, and for the mobility management, we have developed a dynamic and a distributed mobility approach. So what does it mean? It means that in contrary to current and legacy networks, where you have always on mobility context and location maintained in network elements, here we have a fully distributed approach which allows a terminal to move without with more flexibility to use network resources. So in the demonstration, what we show, we have different access routers connected to radio cells, and so when the terminal moves from one radio cell to another one, if it has an ongoing traffic flow, then the traffic flow within the network is redirected from the previous router to the current one. And this is why it is distributed, because all the mobility management features are incorporated in the access routers and no more in centralized network elements like we find in current networks. And it's fully dynamic, which means that if there is no flow to redirect, then there is no need for a new location and mobility context to be set up. So we only perform redirections when there are ongoing ongoing flows. So I can show you now the demo. Here we have an IP network, an IPv6 network, with several access points connected to different routers. So I have one access point and another one, which are connected to different routers within the network. The network itself is using virtual machines, so is incorporated in this PC for them, so it's more convenient for demonstration purposes, but it's really a network with different access routers and a full links between access routers. And here we have a mobile terminal. So okay, for demonstration purposes we use a laptop because it's more easy, but we can incorporate the protocol in standard smartphones with no main issue. So in this terminal, we can see, for the demonstration, we can see the network and the different radio cells that can be used by the terminal. And for demonstration, we control the attachment of the terminal to the radio cell. So if I ask the terminal to move from this access point to this one, so I just control it here. And now it is attached to this one, and this is materialized here on the picture. So here we just use basic Wi-Fi connectivity, like it could be done in a fixed network. And I will show you now what happens with ongoing sessions when the terminal moves. So in the framework of OCONS, we specified a scenario, a scenario which is named flash code connectivity, where at a given time a mobile node, for example, has to upload a large files, large video to servers because it happens some events in its environment and so on. So now the mobile nodes send a video flow to a server in the network, which is received here. So we can see that the flow is routed directly from the mobile node to the access router and to the server using the network. So now there is no specific server used for mobility purposes because it has not yet moved. If now I control its handover, or I force its handover to the other radio cell, it has to maintain its IP connectivity to continue to upload the flow which is shown here. So I trigger the handover, And what happens? So the flow it continues to be streamed on the server, to be uploaded. It's now uploaded through the new access node, and it can be routed directly because it would have to use another IP address which is not known by the server. So we have a mobility tunnel which redirects the flow to the previous access router. So this is the mobility encore, and all the traffic that were established with the address from this encore is redirected through this encore to the network, either in the uplink or in the downlink. Then so this mobility encore is only for maintaining ongoing traffic, but if I set up a new session, for example, if here I refresh an HTTP web page, and then for getting the web page, the mobile node here can use its local IP address. So you will see when I send the web request that there is a new flow here, and the new flow is routed directly to the current location. So this is why it's both a distributed mobility scheme, because the mobility support is located in access routers and no more in a centralized router like it is done in legacy networks. And it is dynamic because this mobility context is set up only for dynamically when it is needed. So when now I stop the upload, so the video is stopped, so the mobile node is no more sending its file, and after a given time, okay, there's a timeout, but after a given time, the mobility context and redirection here are fully erased and no more used. And if I want to send a new video, then it will be sent directly using the current access node. So today it's really what we show here. It's really the execution phase, what we call the execution phase of the mobility. That means that we don't care really about what happens and what triggers a handover, but we manage to show what happens when we have a handover. Okay, it's the execution of the handover. And the next step in the work package will be to integrate with this demo with another demo, which is more focused on the control part, on the preparation of a handover, on getting what are the needed information to prepare and to make a decision to change a flow or a terminal from one access router to another access router. So thank you very much for your attention.
Okay, my name is Luis Diez. I'm an engineer from the University of Cantabria, Spain, and we have developed a subset of the cons facilities so as to evaluate the feasibility of the cons architecture. The demo is the demo consists on a basic network with 2 access points and a mobile node. In the mobile node, we have developed the cons architecture, which is based on 3 kinds of entities: decision, information, and execution entity, and an additional one, the orchestration entity, which can be part of the decision entity. The information entity, which is shown as with that icon, stores information about the signal to noise ratio, while the decision entity collects that information and takes a decision, and finally the execution entity enforces the decision taken. Once the Ocons architecture is launched, all entities are registered in the orchestration entity, and after that it informs the DE about the available entities. At this moment, the DE is able to configure and request for the information from the IE and send an execution request to connect an access point. After the execution, the DE can start the discovery of the remote entities, and we hope to extend the Ocons architecture to more complex mechanisms like dynamic and distributed mobility and so on.